Alright guys, welcome back to this new video and we are going to check an awesome thing out. So there is a kind of like a connection in between binomial expansion and Pascal's triangle. So first of all, we'll see how to draw or write the Pascal's triangle, and we'll see how to use that to get the binomial expansion of any powers. So let's get right into it. The first thing that we are going to look at is how to draw the Pascal's triangle. So the first thing that you need to start with is to write this column 0, 1, 0. That's the first thing. And note that it is considered to be the 0th row in this case. Then to get the row after that, what we are going to do is add these two up first. 0 plus 1 is 1, and these two next. 1 plus 0 is again 1, and after writing that, just put these two zeros to the side. Then for the next row, we are going to add these two. 0 plus 1 is 1, these two, 1 plus 1 is 2, 1 plus 0 is 1 again, and after that just put the two zeros at the end. So let's try doing the third row. 0 plus 1 is 1, 1 plus 2 is 3, 2 plus 1 is also 3, and 1 plus 0 is 1, and in the end we have to put the zeros. So this is how you can construct the Pascal's triangle, and it goes on forever. So Pascal's triangle has a lot of different properties related to logarithms and some hexagonal sides and things, but in this video we are going to focus on the binomial expansion thing. So we are going to use the Pascal's triangle for binomial expansion now. So if they give us a sum, and if that is raised to a power, we can use the Pascal's triangle to expand this into this form right here. So for the first example, let's see how we can expand this one, x plus y raised to the third power. So the first thing that we are going to do is we are going to look at the power. It is 3. So let's go back to the Pascal's triangle, and we have to go to the third row. In this case, this is not the first row, but it is the 0th row. Alright, know this. The first row is always going to be the 0th, and from that we'll proceed forward. So after 0 we get 1, 2 and 3. The row that we want is the third row. So the row we are looking at that we have to know is the third row. So we can just construct the triangle up to that row and then use the Pascal's triangle to do that. So in the third row, we are just going to ignore these two zeros, and the elements that we are left with is 1, 3, 3 and 1. So the thing we are going to do is write the remaining elements like this, in this manner. Alright, 1, 3, 3 and 1. That's the first step that we are going to do. The second step is we are going to write the first term's coefficient, I mean the variable, which is x, and we are going to write it in powers in the descending order, which means we are going to start with x cubed and work our way down to x to the 0th power, just like this. And then for the second variable, we are going to do the same but in the complete opposite. We are going to work our way upwards from the y cube point, like starting from the power y cube and slowly decreasing as we go up. So we have to write it like this, and now we are done with the setup, and now we just basically have to arrange them, and that is going to be our final answer. So looking at this answer right here, what we did is basically write these elements 1 times x cubed times y to the naught or 0th power. So we know that y or any variable or any integer raised to the power 0 is going to be 1. So this is 1. So x cubed times 1 is x cubed. That's what we have here. Then no, and then you should know that the signs are always going to be positive for any integers. Even if this was 5 or any integers up or down, like it's just going to be plus. So we are going to put the plus sign here. And going to the second row, we have 3 times x squared times y to the first power. So 3 times x squared and y to the first power is just y, so we can just put y. And then after that we have to put the plus sign, and looking at the third row, it's 3 times x to the first times y squared. So we get 3 times x times y squared, and lastly we get just y cubed by itself, so we put plus y cubed, and this is the answer when you expand this thing. So let's look at another example, and here we are expanding a plus b complete square. So let's see how we can do this. Since the power is 2, it's going to be in the second row of the Pascal's triangle. So let's go up to our Pascal's triangle, and in the second row right here we have 1, 2 and 1. We have to ignore these zeros, so the remaining elements are 1, 2 and 1. So as I said before, you have to write them down like 1, 2 and 1. Then you have to write the first variable, which is a in this case, and the starting power is going to be 2 since the power here is also 2. So a squared, and then as you go down you decrease the powers. And then in the next row, in the next column, it's just going to be the same but the complete opposite. So we get b to the 0th, b to the first power, b to the second power. So that's the setup, and now we are just going to write the answer down. First thing is to multiply this. So b to the 0th is 1. 1 times a squared is a squared by itself. And then for the second one, 2 times a to the first times times b to the first, meaning 2 times a times b, and that's what we have here. And for the third one, it's 1 times b squared, meaning we are just left with b squared, and this is our final answer. Now I have a question for you, and that is to expand t plus u to the fourth power and to find or verify when t is equals to 2 and v is equal to 3. Basically what I mean here is 2 plus 3 to the fourth power, and you get an answer when you expand this. So just plug in the values to that as well and show that left hand side is equal to RHS, meaning right hand side. So this is the question for you. We will discuss this question in the next video. Thank you for watching this. I'll see you in the next video. Bye.